problems that don't have answers written out on your worksheet, and we're going to work them together right now. So number 6 reads negative 5x minus y equals 14 and negative 10x plus 5y equals 0. Now, because the x's are lined up, the y's are lined up, and the numbers are lined up, we're going to solve this by combination. It's also known as elimination, depending on what math book you read for fun. So in order to eliminate one of the letters, I don't know why I like that word better, the leading coefficient, the number in front of the letter, needs to be the exact same, and I'm going to say the opposite because I prefer to add rather than subtract. So we're either going to get the x's to be a 10 and a negative 10, or we're going to get the y's to be a 5 and a negative 5. So it doesn't matter which way you do this, we're going to end up with the same answers. You probably think you know how, so you might have already solved this problem. If not, you can pause and solve right now. It might be easier to multiply this top one by 5, and then we could eliminate the y's. Or we could multiply this top one by negative 2 and eliminate the x's through addition. If you multiply just by 2, you would need to eliminate the x's by subtraction. So I'm going to multiply by negative 2. So every single term in this top equation is going to be multiplied by negative 2. So negative 2 times negative 5x is 10x. Negative 1y times negative 2 is going to be positive 2y. And 14 times negative 2 is negative 28. This is by no means the only way to do this problem. It is just one of a multitude of right ways. So believe in yourself if you have another way. Here we go. Negative 10x plus 5y equals 0. This equation is just rewritten right there. Now, go ahead and draw a line because we're going to add this top to the bottom. The like terms are going to go together. So 10x and negative 10x cancels. It eliminates. That's why we did this. When we combine them, they're gone. So now we have 7y because 2y plus 5y is 7y, equaling negative 28 plus 0. So that's just negative 28. So to solve for y here, you would divide by 7. And y would be negative 4. Now, the solution to a system of linear equations is 1 point. They're going to cross in 1 point. So you could plug this back in to either of the initial problems and solve, but that first initial problem was kind of easy to solve by multiplying that by 5. So I'm going to actually leave the problem up there, and this time, let's multiply the top one by 5. So the new top equation is negative 25x, because 5 times negative 5 is negative 25x. I'm going to put plus negative 5y. You can leave it as minus 5y. It means the same exact thing. And then 14 times 5, you could multiply this out and get 70. And you could grab a calculator too. And then the bottom equation is still the same. So when you go to eliminate now through addition, the y's will cancel. You're going to get negative 25x and negative 10x is negative 30x equaling 70. And that's a 35 because that's what 25 and 10 is. Okay, so this is great. It's easy to solve. So when you divide by negative 35, you're going to get x is equal to negative 2. Now, I'm going to just plug this into both of the equations. If you solved by plugging the negative 4 into one equation, plug the ordered pair into the opposite equation just to check. So I'm going to check through both to make sure this works. So the question is negative 5 times negative 2, because that's what x is equal to, minus y, which is negative 4, is that equal to 14? So negative 5 times negative 2 is 10, minus negative 4 is plus 4. That is equal to 14. So it works for that one for sure. And now let's check the other one. So the second equation is negative 10 times x, which is negative 2, plus 5 times y, which is negative 4, is equal to 0. So this is a positive 20, this is a negative 20, so that one works too. So now you are so sure that that answer is correct. Next problem in your book that isn't solved is number 7, and it reads negative 4x minus y is equal to negative 10, and 12x plus 9y is equal to negative 18. So in order to eliminate one of the letters, the leading coefficient needs to be the same, and if you want to add to eliminate, it needs to be opposite sign. So we either need to get the leading coefficient of the x's to be a 12 and a negative 12, or we need to get the leading coefficient of the y's to be in a 9 and a negative 9. That's pretty easy to do. Right now, the leading coefficient of this y is a negative 1. So if we multiply this by 9, we could eliminate the y's. This one's also really easy to eliminate the x's because if you multiply everything by 3, you'll get negative 12. So let's do this problem the same way as the last one where we solve both of them just through the whole initial elimination. That was fun. So here we're going to eliminate the y first. You could do the x first. You can hit pause, see if you can do it. So multiplying by 9 to eliminate the y and solve for x. The new top problem is 9 times negative 4x, which is negative 36x, minus 9 times 1y is just 9y. You might want to make that plus a negative. It's the same thing as minus. That's an option. I really like plus a negative. And then 9 times negative 10 is negative 90. The bottom equation stays the exact same as it is. And then we're just going to line that up, and we're adding to eliminate because adding is what makes the y's cancel. So when we add, those become a 0. Negative 36 and 12x is a negative 24x. And negative 90 plus 18, that's making me think for a minute. So that's going to be negative 72. And when we divide by negative 24, we're getting x is equal to 3. Negative over a negative is a positive. So now we're going to solve for y. You could plug the 3 in to x and solve for y up there. But you could also do what we did in the last problem. So I'm going to erase everything below here. And in order to eliminate the x's, they both need to be a 12, with the 1 being the opposite. So if we multiply the top equation by 3, that will happen. 3 times negative 4x is negative 12x. 3 times negative 1y is a negative 3y. So you can have minus 3y or you can have plus negative 3y, whichever one works for you better. And then 3 times negative 10 is negative 30. So the top equation is now multiplied through by 3. The bottom equation stays as is. I'm just going to rewrite it exactly as it looks. And then in order to eliminate, we're going to add, because a negative 12 and a positive 12 cancels to give you 0. So negative 3y and 9y is 6y. Negative 30 and 18 is negative 12. And when you divide both by 6, you get y is equal to negative 2. So it's appearing that our ordered pair solution is 3, negative 2, because the ordered pair solution is x and then y. It's over and then up. So let's check this. It's always good to check if you can. I make mistakes all the time, so why not check? So I'm going to plug it into both of these equations since we solved both of them through elimination. I'm going to erase all of this just so I have a little more room. Okay, so negative 4 times the x value, which is 3, minus 1 times the y value, which is negative 2, is it equal to, that's the question, the negative 10. That 3 is what we had multiplied by, so I'm just going to erase that also. All right, so negative 4 times 3 is negative 12. Negative 1 times negative 2 is positive 2. Check it out. That is equal to negative 10. So it works for the top one for sure. Let's check the bottom one now. So 12 times x, which is 3, plus 9 times y, which is negative 2. Is that equal to 18? That's the question. So this is 36, and 9 times negative 2 is negative 18, and it is. So now, with 100% certainty, you know that works for both. And again, you didn't have to solve it the same way I did. You could have even solved this by substitution, except I think the worksheet said elimination, but if you wanted to solve for y, you could plug it in. It's set up to eliminate since everything's lined up. So the next problem on this sheet that wasn't answer keyed is number 9, y equals negative 8x minus 7, and y equals 9. I'm just looking at this quickly thinking I could plug 9 in for y. I could substitute just to know where they cross. So 9 equals negative 8x minus 7. So you would solve for x by adding 7. So 16 equals negative 8x. And if you divide by negative 8, then x is equal to negative 2. So right now, I'm pretty sure that negative 2, 9 is the solution. I mean, I know it's the solution. I'm not pretty sure. So we're going to go ahead and solve by graphing. So we have this lovely hand-drawn graph. We do need to get to negative 2, 9 to show the answer. So if we make a table of the points we're going to graph, y equals 9, x can be any single number. But I should put negative 2 first and then negative 1. Because y is always going to be 9 in that. And then right here, I definitely know I need to start at negative 2, and then it's going down by 8 every single time. Plug negative 1 in. Negative 8 times negative 1 is 8, and 8 minus 7 is 1. You see how that goes down by 8, just like the slope? So 0 is going to go down by 8 again, so that should be negative 7, which it is. That's the y-intercept, and so on. So it appears we need to get to up to 9 on the graph and down to negative 7. So your graph is already given to you. So this would be negative 7. All right, so negative 2, 9 is where both of these lines are going to cross because they both are at negative 2, 9. And we also solved that initially with substitution. Now, the y equals 9 is going to be a horizontal line because you're going to graph negative 1, 9, over 0, up 9, over 1, up 9, over 2, up 9. Every time you have a y equals, you have a horizontal line. Whoa, just pretend that's perfectly straight. And then this right here, negative 2 gives 9, and then negative 1 gives 1. So this is a pretty darn steep slope. It does have a slope of negative 8, so that makes sense. It should be going down pretty darn fast. And then 0 gives negative 7. So this line, I might grab a... Oh boy. I don't know who wrote this on here, so that is the steep line with this being the intersection point. So when you're graphing these systems of equations, you really need to make sure that you find the intersection point. To me, the hardest way to solve systems is with graphing. I kind of think it's a pain. So I would take the graphing situation and figure out either through substitution or elimination the easiest way to figure out the ordered pair point that they cross, and from there figure out what points I need in the graph. You're more than welcome to just start graphing this, and if you're in the positives, you're going to realize that these are not going to cross because this is going this way and this is going down. So you'll definitely need to make sure you go into the negatives to get where they're going to connect. If two lines have a different slope and a different y-intercept, they will connect. You will get a point where they cross. So this is your solution. Negative 2, 9, and if something does say solve by graphing, then you do need to have a graph. You don't have to necessarily initially solve by graphing though, but you do need to have a graph. So the last problem on that sheet that wasn't solved for you is this. And it does say solve by graphing. Now I'm looking at this, noticing that the slope is the same and the y-intercept is different. So I'm expecting a graph to be a pretty flat negative slope where it's never going to cross. So I'm thinking this is going to be no solution because we have two parallel lines with different y-intercepts. Now, if you were to try to solve this with substitution, because this is equal to y and this is equal to y, you could set them equal to each other. You could set this equal to this because they're both equal to y. And then if you have something like this, you would put all of the x's on one side. So you would add the 1/4 x. And the x's cancel. So now you're going to have -9 equals 4. Now, that's not true. So that's why the answer is no solution. If these were the same exact number and you got the same number, then you would have all solution because the line would actually be the exact same line. So in order to graph this the easiest way, I would say you could generate a table, but you could also just start this at 0, giving you -9. And then as you go, this is rise over run. So as you go up by 4 in the x, you're going down by 1 in the y. So 4 is going to give you -10, and you can check that. 4 times -1/4 is -1, and -1 minus 9 is 10. This is the -1, which is your rise, which is the rise, and this is 4, the run of 4. So as you go up by 4 again, at 8, you're going to be at -11, and you can check that. 8 times -1/4 is -2, -2 minus 9 is -11. And then if you make a table for this other one, it's the same exact theory of 0 is going to give you 4, and then as you go up by 4 in the x, you're going down by 1 in the y. So 4 is going to give you 3, 8 is going to give you 2, 12 is going to give you 1, and 16 is going to give you 0. You can check that. 1/4 times 16 is -4, and -4 plus 4 is 0. So when you go over here to graph, I know your graph is given. I just can't remember what it looks like. So because of the 1/4, I'm going to just count by 4s in the x's. And then in the y's, it looks like I need to get to -11 and up to 4. So I'm kind of thinking I should have started this higher, which I'm just going to do. So I'm counting by 4s in the x, but I'm just going to count by 1s in the y. So this equation, 0 gives -9, 4 gives -10, 8 gives -11. So this equation looks like this. Now, this slope, it looks like a slope of 1 if you were to figure out the rise and the run. But remember what's so important is the scale. So this has a run of 4 and a rise of 1. So that's how we know that this slope is -1/4. It's going down, so it's negative. And then the slope is rise over run. All right, the other equation is right here. So 0 gives 4. 4 is going to give 3, 8 is going to give 2, 12 is going to give 1, 16 is going to give 0. So provided that I space this out perfectly, these two lines should be completely parallel, both with a slope of 1/4, and that's how you know the answer is no solution. So I hope that worksheet has really helped you make sense of substitution, elimination, graphing. Go ahead and try the story problem worksheet of when to use which, and then take that quiz on Google Forms. Have a great week. Good to see you again.